Hey guys, so today we're going to do Unit 5, Lesson 1, and so we're going to look at exponential functions a little bit and start looking at those. So your warm-up question asked you to draw some bacteria. It told you that the bacteria in the first hour, or hour 0, and hour 1, so the first one you would have to know that this was hour 0. And then after the first hour, so hour 1, the bacteria had gone from 1 bacteria to 3 bacteria. And it wanted you to draw a diagram to represent hours 2 and 3. And so what you should have drawn was something similar to this. So if you knew that this 1 bacteria split into 3 bacteria, then this bacteria has to go into 3, this bacteria has to split into 3, this bacteria has to split into 3 at the hour 2. And so that would give you 9 bacteria. And then for hour 3, those 9 bacteria would each split into 3 more bacteria. So you would have a total of 27 bacteria, or 9 groups of 3. Okay, so this was our lead-in into looking at what happens when you raise something to a power. Because you have 3, if you take 3 bacteria, or if you take 1 bacteria and you split into 3, then you're going to get 3. If you take these 3 bacteria and you square it, you're going to get 3 squared, which is 3 times 3 is 9. If you do that again, 3 times 3 times 3, you get 27. And so that's our lead-in into exponents that we're going to look at. So then we're going to look at this question. So you're walking along a beach here and your toe hit something hard. You reach down, you grab onto a handle, and you pull out a lamp. It's really sandy, and you start to brush it off so that you can see how shiny it is. And a genie pops out. He says, "Thank you for freeing me from this bottle. I was getting claustrophobic. You can choose one of these purses as a reward. Purse A is going to give you $1,000 today. Okay, so you're going to get $1,000 right now. If you leave it alone and you don't touch it, tomorrow you'll have $1,200. Okay, the next day it'll have $1,400. So this pattern is giving you $200 additional dollars every day, and it'll continue as long as you don't touch the purse. Okay, sounds pretty good. Well, what about purse B? So there's a second option here, purse B, and it's going to give you 1 penny. Who's excited? 1 penny, yay! Okay, but if you leave that penny there, it will be 2 pennies tomorrow. I think purse A looks pretty good. Well, the next day, there will be 4 pennies, and so the amount in the purse is going to double each day. So let's look at this. Purse A, we start out with $1,000. Purse B, we start out with 1 penny. Kind of a no-brainer if you're going to open that purse up on the first day. But what if you leave that purse for a whole week? How much money is going to be in purse A and purse B after a week? Well, since we know that purse A is gaining $200 every day, we're going to start out with 1,000. So we're going to have $1,000 plus 200, and we're just going to multiply that value by 7. So 1,000 plus the 200 times 7 days is going to give us $2,400. Purse B, on the other hand, we have 1 penny. So we want our answer to be in dollars. So we're going to write it at 0.01 to represent a penny. And we're going to multiply that by 2 because we're doubling it. So every time we double it, you're going to change the exponent. So if I double it once, so 2 to the first power, I'm going to get 2 pennies. If I raise that to the third power, I would get 4 pennies for the third day. And so if I raise it to the 7th power, I'm going to end up with what day 7 would be. And so that's going to give you $1.28. So after the first week, I bet everyone's going to pick purse A. Okay, stay with me. Let's see, what about after 2 weeks? We're going to use the same kind of equation here. And so after the first week, purse A looks really good. After the second week, purse A is still looking pretty good. What about 30 days? So same equations, purse A, now multiplying 200 by 30 and then adding the initial 1,000, and I only have $7,000. $7,000 sounds pretty good. But what about that penny over here on the other hand? I raised that to the power of 30, which is what that should be right there. 30, not a 7. Okay, if I raise that to 30 to look at 30 days, I'm going to end up with $10 million. $10,737,418.24. I don't know about you, but I'm thinking that I could leave a purse, not touch it, for 30 days to get $10 million. So on your next couple of questions, you're gonna answer these and also find how much money would be in those purses after 3 weeks. Okay. All right, let's look at this graph. So we've been doing linear functions, and if you look at this graph, you can see 2 sets of dots. So we have these red dots. These represent the first function, so purse A. So you start out with $1,000, and every day you're going up by $200. And so by this first week here, you would have that $2,400, and it's just increasing. So it's just 1,000 plus 200 times the number of days that you want. So whatever number of days you want to look at, we can plug that in for X, and we would figure out how much money we would have. Now, if you look at the blue dot, this is our new function. So the red one is linear, but this one is where we were changing the exponent. And you can see that it starts off really small. Those first couple of weeks, it didn't make very much money because we started out with a penny. And when you double a penny, it doesn't go up very fast. But you can see that at about, at day 16, so like right here, you can see that it goes up much more quickly than it did previously. And then even after 20 days, that's a big jump from like all the way past $10,000 there. So you can tell that it's going up way more quickly. And so this is what an exponential function is going to look like. Anytime we raise a function to a power, you're going to get this line where it gradually goes up and then it shoots up really, really quickly. But anytime you double a larger number, it's going to be significantly higher than just going up like a linear function has in the past. Okay, by looking at this graph, is it easy to kind of choose which purse you would want? I mean, this function seems way, times 2 to the power of X. So that's our exponential function because our variable is now the exponent. So we're changing the exponent, where in the linear function, we're just multiplying by a factor. And you can tell, looking at this line, purse A seems like way less money than purse B after 20 days. Pretty much anything past there, or the point where they intersect here is this point right here. So at 19 days, it wouldn't matter which purse you had. But after that, you would definitely want to go with purse B. Okay, so that's our little intro into exponential functions. You have some practice problems, and we'll look at these a little more closely throughout this unit.